Presenting today is Randall Echterling, Network Architect for WellSpan Health. Randy has been with WellSpan Health for the last 10 years and is responsible for the design and development of the network infrastructure. Prior to working at WellSpan Health, and before having two beautiful girls, Randy worked as a consulting engineer with an information system integrator. Randy has 25 years of experience in the industry, including transport networks, i.e. SONET, DWDM, CWDM, and more, along with LAN and WAN topologies, i.e. switched infrastructure, wireless, MPLS, E-line, ELAN, E-tree services, and more. We're pleased to have all of you join us this morning, so without further ado, I'd like to turn the presentation over to Randy and get things started. Randy?
Thanks, Jake. Well, my name is Randy Echterling. I'm the Network Architect for WellSpan Health Systems. But I'll tell you what, for the next hour, why don't you just consider me your tour guide as we embark on an image and a solution here of visibility fabric. So just sit back and relax and tell you what, why don't you take my hand and let's just go through the visibility fabric. I want to start out first by talking a little bit about WellSpan Health. So this way you have an idea of who we are, what we do, and why we do it. A little bit of that background will help you in seeing what we needed to do for our visibility fabric, what visibility fabric is, how we utilize it, and what the future holds. So WellSpan Health, we're a not-for-profit community-based health system. We're located in 3 counties in central Pennsylvania, which would be York County, Adams County, and Lancaster County. Currently, we have 4 community teaching hospitals. That is our main hospital in York. We have a rehab and surgical hospital also located in York, Pennsylvania. We have our Gettysburg Hospital located in Gettysburg, Pennsylvania, and Ephrata Community Hospital located in Lancaster County in Ephrata. Now, all the hospitals together, we're about 800 beds. That number varies a little bit depending on any kind of work that's going on in the hospital and just remodeling in certain areas. And we have about 100 remote practices, but they really comprise about 93 locations. Some of them are multi-tenant, so we have multiple locations, multiple practices at a single location. We have those throughout central Pennsylvania, so it would be really in our Adams, York, and Lancaster counties, plus we have a few practices in Maryland. We have about 10 pharmacies distributed around those 3 counties, and we fill anywhere between 750 to 1 million prescriptions on an annual basis. Now, we offer a ton of other services for heart and vascular care, oncology. We have our women's and our women's and imaging facility, and that facility has our women's health, all of our imaging, PET scans, MRIs, any kind of imagery that you want. We're a trauma level 1 for adults and a trauma level 2 for pediatrics. We do a lot of work with stroke protocols. We've implemented our own video solution to handle patients when they come in that could possibly have a stroke, to get them the best possible, quickest care that we can give them to increase their quality of life after they have an event like a stroke. We offer our visiting nurses, and we have home care that's also offered, as well as there's a specific section of our business that deals with the hospice. That would be our PRN, they call it a PRN special touch. So that was really just the overview of WellSpan Health, the things that we do. We're a community-based hospital health system, so we're really going to be focused on the community. We're going to be focused on how we can help people and what we can do to improve quality of life for people that have had problems that need to come into the hospital. need to come into the doctor's office? How can we reduce anxiety? How can we help them? How can we make their life better? There's a lot of questions that people have about visibility. You know, what is visibility? Everybody talks about network visibility. And if you ask 10 different people what their concept of network visibility is, you might get 10 different answers. For us, network visibility is awareness of applications that we have. What's moving across the network? What's moving across our WAN? What's moving across our LAN? What is our centric applications that, and how are they working? Sometimes we don't understand fully how applications work. We have to put them in as a proof of concept and just understand how they communicate, what bits and pieces communicate. Visibility gives us the concept of we can see what's happening on our network. We're aware of the applications that are moving. Now, we talk about why do we need it. Awareness gives us the ability to understand how those applications work under normal circumstances. So if you know how the application is working under a normal condition, then when the application is giving problems, it's easy to pick out the abnormal and say, wait, that's outside the normal baseline. That application may be having a problem. So it's great to be able to get an application in, baseline it, examine it, see how it's going to perform, what it's going to do on the network, how it's going to operate. Then we can take that information, use that as a baseline to develop in any analytics tools, and then, hey, if it's not performing that way in the future, what can we do to correct that, and what's happening? So that's really what we look at for visibility. The awareness, and then once you have that awareness, how you can use that to baseline. So I always encourage people, whenever you put any kind of solution in, you always want to make sure you baseline application. Now, if you go ahead and implement the solution after an application's already been put into place for any kind of visibility, then there's a little catch-up that has to be done. You don't have the benefit of having everything in place prior to a new application coming online. But we'll talk about that. We'll talk about that in a minute. And I talked a little bit before in a previous slide of why we need it, but I'm going to drill down to a couple of key concepts here. Networks are becoming complex. Show me a network that's not becoming more complex. Doesn't matter whether it's healthcare, doesn't matter whether it's an enterprise solution, a manufacturing solution, whether you're delivery, whatever the case may be, the networks are going to become more complex. Part of it is, that's great for us to say, all right, networks are complex. Hey, we know we're going to have a job because we're going to have to build it. We're going to have to troubleshoot it, and we're going to have to make it better. But as anything that gets more complex, we've got to be careful. We don't want to make the network so complex that we guarantee failure. If you make the network so complex that your staff isn't able to support it, then you've built in too much of a level of complexity. You've built in a failure. It's not if it's going to fail, it's when it's going to fail and what is going to be the cascading effects. You put in a complex network, it fails. You have nobody that can troubleshoot it. Now, it's going to be a cascading effect. You're going to have to troubleshoot people that aren't used to it or don't know it, are familiar with it. It's going to have a learning curve. So to resolve a situation is going to take a lot longer. We need to have a proactive issue detection. So we need to look at things before they happen, before they're perceived. So once an event starts happening on the network, it'd be great to get that information and know about it before we start getting calls rolling in. Because the great thing is, if we could solve that before people notice it, before it becomes a perceived problem, then they just keep working and don't realize anything's going on. This way we can always be ahead. So in healthcare, we look at it and be proactive. Why you go to a doctor for a physical, why you get checkups. You want to be ahead of that. You don't want to wait until you have a problem. Now, we also have to examine traffic for compliance standards. For us in healthcare, we have HIPAA that we have to do. But we also take credit cards, so we have to do PCI. Other people may not be involved with the HIPAA component of it as much, but they're doing a lot of credit card processing, PCI, whatever. We have to make sure that we're compliant for HIPAA regulations, compliant for PCI, and any other governing body that requires a compliance. So that's a big thing, because if you're out of compliance, there could be fines. So getting that awareness of what's moving across your network, maybe you don't realize there's an application that's moving across that's transmitting credit card information in the clear. But by now having some kind of visibility fabric in there, you can discover that. And when you discover that, then that allows you to correct the problem and maintain and stay in your compliance, because it's better to find out ahead of time than it is to have a reported event. In the case of healthcare, the reported event could be a HIPAA event. If we lose protected health information, then we would have to put an ad out in the paper to tell the local community that we lost information from patients. Now that can be detrimental, as well as you see companies will lose credit card information, and they had to do the same thing. People's credit cards got compromised. They had to notify credit card companies. They had to notify went into the press. A lot of that can be bad publicity for any organization, regardless of healthcare, enterprise, whatever the organization would be. So the other reason for visibility is, with networks growing, we can look at that information and we can trend and profile applications. We can plan for capacity to say, oh, hey, that application performed this way for this many remote sites, but hey, we're going to have double our number of remote sites. Well, maybe we got to change our WAN links. Maybe we've got to increase that. Maybe we need to increase our backbone. It gives us the ability to look at areas that we may need to improve our network in order to provide the level of service that we need to for our customers. Now, whether that be healthcare, it be patients, doctors, but industry, regardless of the industry, there's a customer out there. And whether we treat them as an internal, whether they're internal or external customers, there's a customer out there that's relying on the services that ride on that network. So our ability to look at that profile, plan, and plan for critical business apps. Now, in the healthcare arena, we have probably about 60 or 70 critical business apps that run here at WellSpan. Some organizations might only have 2 or 3, but you'd have to determine what those critical apps are and baseline those, plan, and profile and plan. No matter what industry we're in, there's always somebody out there that's trying to break in. If you've got a connection to the internet, you have wireless, there's always going to be somebody trying to break in. So in healthcare and in industry, in any enterprise industry, you have the ability to put in IPS for intrusion prevention or intrusion detection systems. The great thing is, if you take and build a visibility fabric, that data can be fed into the IPS and IDS with everything that's going on in your network. So it gives the ability to look for malicious traffic. Hey, is somebody doing something that they shouldn't? Somebody going someplace that they shouldn't? Do we see any particular type of traffic that's dangerous? There's tons out there. I mean, you could be running SQL injections. You could be doing a lot of other attacks on the network from just an infected PC that the user doesn't even know. That's the great thing about doing IPS and IDS and using that data. Let's put it, just bluntly. We rely on the network. Show me somebody that doesn't rely on a network today. All industry does. Doesn't matter whether it's wireless, whether it's wired, cellular, radio networks, internet, we rely on it. So think about what would happen to your business if your network wasn't down. I mean, if your network was down, it wasn't available. In healthcare, we'd have problems treating patients. There's ways that we could still do it, but we wouldn't be able to do it as effectively, being that everything's electronic in the medical record. So you're trying to treat a patient. If you can't get to that medical record, there's no paper charts to go back to. So you have to build in redundancy. On a manufacturing environment, and when I was consulting, I did a lot of work for different organizations that would make truck axles, heavy assemblies, whatever the case may be. You're running a machine that's cranking out parts. That machine's done with that run, goes back to communicate and pull the next batch. Hey, if that machine can't get that information as soon as it's done with its run, it stopped. You could grind a manufacturing floor to a halt if the network is not available. For healthcare, what's driving the need for visibility is our patients. That's really it. What services can we deliver to our patients? In this case, you have a patient that might be hooked up to an infusion pump or a vitals monitor or a physiological monitor. Any one of those systems. Some of those will communicate back across wireless. Some are going to be wired. But all that data gets fed into the medical record. So you have a patient that's hooked up to an infusion pump, and that infusion pump is providing them a certain medication, certain drip rate. You want to make sure that that drip rate's happening, so that data gets put back in the medical record. In addition, a doctor anywhere can access that information. Could be on the network, could be VPN. They can access that information, and they can make a change to that infusion pump to change the drip rate. So they're getting the vitals monitors that's giving blood pressure, that's giving pulse rate, that's giving temperature. That's being sent in. Physiological monitors that could be giving, it could be an EKG, it could be a cardiac monitor, it could be any monitor that's monitoring. We have monitors that can monitor 16 or 17 different physiological aspects of a person. Pulse ox. All that information is fed back into the EMR. The doctor could sit there, he could look at waveforms, he could look at all of the information history. He could be sitting anywhere in the world on a VPN. And he could say, you know what I'm going to do? I'm going to go into the EMR, I'm going to change that drip rate, and I'm going to send it to the infusion pump. He changes it, automatically changes it in the infusion pump. There's no transcription error. It's a nurse isn't going to fat finger something. She isn't going to flip 2 digits, put the wrong drip rate in. Everything is programmed, and then the pump reports back to the EMR to make sure that, hey, you told me to do this. This is what I'm delivering. So then the doctor can check on the patient, can look at him remotely. So the quality of care can go up because the doctor does not have to do all of his rounding to see every one of his patients. He could be sitting at home seeing patients, seeing all of their results at night and making adjustments to their medication on the fly. And each of those pumps has a drug library built into it, so it'll allow you to administer anything within a safe range. Then there is the not so normal but still safe range. That requires a nurse override to go over to the pump and say yes. And then there is a lethal or a dangerous level where it'll say, hey, I'm not going to dispense it no matter what you tell me. So the doctor has the ability to adjust care. Now, this is in a healthcare environment, but there's a lot of other situations like this that could be anywhere for any manufacturing environment, for any delivery environment. for any construction organization, anything like that. There's things that would be specific to them. In this case, this is specific to healthcare. But it allows us to deliver a better quality of care. So information that we had before sometimes was meaningless. You've got a lot of data that just seems meaningless. Just like this sign, hey, caution, the sign has sharp edges. Don't touch the edges of the sign. Oh, and by the way, the bridge is out ahead. So we get a lot of information, and sometimes weeding through it and finding really what the problem is hard, is difficult to go through massive amount of data. So the way we worked things before is, hey, we based it upon a user trouble ticket. User would call in. Okay, that's great, except the user now perceives that there's a problem. Hey, wouldn't it be great if you could avoid the user calling in and telling you that there was a problem? That would be awesome. That would be awesome if we could avoid that. We can use SNMP to gather information about what's happening on an interface. So there's tons of applications out there that can get SNMP utilization. At WellSpan, we use SolarWinds. We use Orion platform to gather SNMP information. And it tells us, hey, your interface is at 90%. Okay, so my interface is at 90% utilization. Is that one user? Is that 100 users that are consuming that bandwidth? What applications are consuming that bandwidth? Other than telling you your link's saturated, you don't really know much more. It's just like the oil light in a car. That's going to come on pretty much when you're out of oil. You have no detail about what's happening. You'll lose that. So there's other ways to do it. Hey, NetFlow is a great tool to use, and it gets you granular information about what happens. The problem is, as you move more towards higher speed, you're going to miss things because vendors are starting to do sample NetFlow. So now you're not seeing every packet that's moving across the NetFlow. You're seeing 1 out of 4,000, 1 out of 8,000, 1 out of 12,000 packets. So we use the CRS line ASR 9Ks in our core. Well, hey, those are pretty much going to be sampled NetFlow. So NetFlow data from them isn't really going to be useful. When you've got a system that's packed with 10 gig interfaces, that's got 60, 70, 80, 90, 110 gig interfaces, or 100 gig interface, or 40 gig interfaces, how much bandwidth are you going to be using to take NetFlow? How much CPU processing are you going to be using? Well, that's why they did it. That's why they went to sampled NetFlow, because CPU utilization would just be way too high. So it's great for some things, but other things NetFlow is not that great. Now we could modify span and capture VACLs. These are ways that we could do this. We could configure a capture VACL on a system, or we could configure a span port. But any core change, any change in our network infrastructure for us requires 14 days. So it requires 10 business days. So if I want to make a change to a span port, I can't just make it now. I have to put my request in and wait for 14 days. Okay, well that doesn't work. Okay, so I don't want the user trouble tickets to come in. I want something better than SNMP. NetFlow isn't going to cut it on my platforms, and it's too much time to do a request for change to find a problem. So now, what's my solution? What am I going to do? And here's what we came up with. We decided that we're going to tap every fiber link. Most of our data center and our core connections are all fiber. So we decided right off the bat, instead of going through this trouble of span ports and port span capacity and capture VACLs and all this, when we install a piece of equipment, we're putting fiber in, we're going to put a tap module in. The only difference between a regular cassette that might have an MTP connection on the back and LCs on the front for a fiber breakout for a fiber plant, the only difference between that and putting a tap module in is the part number. We could drop a tap module in and tap every connection. So what we do is we decide we're going to build a fan-out area where we take our equipment that we put in, our Nexus 7Ks, our Nexus 5Ks, any of those, and we use the Cable Express taps in that scenario, and we fan the equipment out. When we put in a new card, we fan it out and we present it on a separate fiber panel so that it's away from the equipment. You're not actually touching the equipment. You're touching that panel when you do a cross-connect to go to a rack, go to a different area in the data center. And we present that equipment right there. Guess what? We use a fiber tap, we use a tap module right off the bat, plug it in, we're done. Whether we connect that on the back end to a tap breakout, it doesn't matter. Once the module's in place, we don't ever have to break that fiber again to put a tap in. It's done. For other special runs, we'll use smaller half-U taps that we can put 4 taps in a half-U. We have those distributed around, and we use a lot of the Gigamon taps for that. We've used other taps. We have Network Instruments taps and a few others, but we like the Gigamon because of the half-U functionality. But the Cable Express taps work awesome in the panels, so they plug into the H-series, and we just break it out right there. Well, hey, so we've got the capability of visibility on every one of our links, even if we don't use it day one. Now, we have AppCon systems, we have Gigamon systems, and we bring that tap data from the Cable Express taps over into aggregators. We have Fluke, we have Datacom systems, we've used NetOptics, we've used VSS. You know, on a conversation I can tell you goods and, you know, what's good and bad about everybody's out there. We've pretty much had them all in at one point or another. We take the data coming from the taps and we run those into the aggregators. Those aggregators then take it to a core system that has the intelligence. And you can refer to them as directors, but we take that data and then we send it to our analysis engines. So we have a long-term storage system where we have a couple of Network Instruments boxes with 64 terabytes, and they just kind of hang out there and they just capture long-term data. But we also have our, if anybody was familiar with the OpNet product, which was bought by Riverbed, it's now called Steel Central App Response. That's how we do our application performance monitoring. All of our APM is done from that. And the great thing is when we get into the intelligence of the directors, we can say, hey, any traffic that matches voice, hey, send over to this ARX system. Any traffic that matches our applications based on a list of IPs that we give it, a list of traffic type, whatever, we could send over to a completely separate appliance. So it's great. So now I'm pulling the aggregators, I'm bringing them in, I'm putting them in the low-cost aggregators, bring them into these intelligent directors. The intelligent directors can sit there and say, hey, you know what? So first of all, let's dedupe all the data because I might see that same data at multiple points in aggregation because I'm physically tapping links. So let's dedupe everything, hey, because we don't need to process anything extra that we got because we're getting all this information. So let's dedupe everything first. Hey, now, is there anything special that we need to do? Do we need to strip headers off? Do we need to, depending on if it's MPLS, we might strip those off first, then do the dedupe. Do that deduplication. Then we make a decision based on that application. What do we need to do? Maybe that application gets sent raw over to an analysis system, or we say, hey, you know what, we're going to send you over to the long term, but we don't really care about the payload. So we're going to do some packet slicing. We're going to chop that off, and we're going to send, you know, we're going to send just the header information in for storage and analytics because we don't care about the image. We're not storing, if it's coming, you know, traffic from a modality, which is an MRI or a CT or any kind of imaging equipment, we don't really care about the payload. We want to cut that off, and just keep the data so we can get the analytic piece of it. Also, we run a product called Transaction Expert, which is a Steel Central Transaction Expert now, and that allows us to pull the data from remote capture agents that can be running on every PC in the environment, and even servers, and we can pull the data from them. We can pull the data from the ARX that it gets from the taps, and we can put that together. And we can not only see what the client sees, what the server sees, we can see what the network sees from the ARX. So it gives us the ability to get an end-to-end view of what's happening from everybody's perspective. What does the client think is going on? What does the server think is going on? And what does the network show is going on? And we can bring that all together. One of the key things is we have an application called App Mapper, and that maps out application flow. So we can take all of the data that we get from captures, that come from the visibility fabric, that come from the analyzers, and we can pull that in, we can throw that into App Mapper, and it'll tell us who's communicating with who and build a matrix to say this system is communicating with this system, doing SQL calls over here. Oh, hey, I'm figuring all my clients are talking to my front-end servers, and my front-end servers are doing SQL calls to the back end, and then lo and behold, and this is a real-world scenario, I found clients doing direct SQL calls. Why do I have a client doing direct SQL call to the SQL database when everybody should be going through the front end? They should be going through those front-end servers. And we had to take that back to the manufacturer and say, what's going on here? And then we discovered that under certain circumstances, depending on certain things that they're doing, it'll do a direct SQL call. Okay, that wasn't profiled initially. We didn't understand that. We understand how the application was put together, but you know what? There's little things like that that are missed. So having an application like that, where you can look and see what the app flow is really beneficial. In addition, we have an application called NetMapper, which is a network mapping tool. It allows us to build a hierarchy of our network. It creates everything and builds it in pretty much a Visio diagram, but it's interconnected diagram. So you can click on one, it'll open up another. So you build a hierarchy. Say, okay, I'm going to define this area as my core. This is my distribution. This is my access. This might be one facility in the hospital. So in our main hospital, we have 63 access closets that are distributed around. Some of our other facilities, we have a smaller number. It might be 12, might be 4. Depends on the size of the facility. It might be 20. But it gives us an idea to build that hierarchy. In our main hospital, we have 3 different distribution points, so we can get an idea of what access areas are out of each distribution. And it's a nice way to kind of put that into play. So now, here's putting it all to work. I'm talking about the taps, and I'm talking about the opnets, and I'm talking about all of our directors. And let's just lay it out here. So my ASR9K cores, this is just showing 2 of my data centers. Those are my cores, tie into the core network that goes to all the other hospitals. But between that and our Nexus 7K series, we put taps in play. Those taps, in this case, we use Gigamon taps because those are a limited number of links. Now, everything that goes from the 7K to our 5Ks to our 2Ks to our 6Ks, any of that, we present those as fan-out fields by using the Cable Express taps, so that we take our 7Ks, fan them out, get to the 5Ks. Our 5Ks are all fanned out. They go down to 2Ks and so on. And we're in the process now of putting 6004s in, which are going to provide our 40 gig spine. So we also had to do something a little bit different because we're using bidirectional optics there. So there's some unique properties where you have to take into account bidirectional optics. So you're getting light transmitting in both directions on the same, at 2 different wavelengths on the same fiber string. The problem that you have is you can only tap, the current taps allow you to tap in one direction by doing almost like a tapered split. So you get an infinite loss projecting light back the other direction. So there's specific taps that we use for BiDies. So we have our regular taps, our BiDie taps, our Cable Express taps, it's a mixture. Now, that data that's picked up by those taps, we usually use a 50-50 split tap, which are rated for 10 gigs. And we get that over to what we call our traffic cops, our gigamon. They can be our aggregators. In some cases, they'll go to the aggregators and then they'll go to the directors. In some case, the core links will go directly to the director systems. And then in there, we provide our intelligence of doing the slicing, the dedupe, the header stripping, all of those pieces. Now, we have a DWDM link that ties our data centers together. So at this point, I've got 2 active loops. I have a 32-channel loop going in each direction, so I have 64 channels at 10 gig per channel. So I have the capability across 2 pair of fiber to deliver 640 gig. On my new system, it's 80 channels. It's 40 channels in each direction. So I have 80 channels at 10 gig per channel right now. The nice thing is, the way that they are designed in the DWDM space is I can run coherent optics and I can make them 40 gig or 100 gig channels. So I have the capability on 2 pair of fiber to deliver 40 channels on each pair. That 40 channels could be 100 gig. 40 channels is 100 gig. We have the benefit of owning our own fiber between the data centers and our primary hospital, our York hospital, which is about 1.2 million square feet under roof. But what we do is we use a couple of those DWDM channels to tie our intelligence together. And right now, we just have them as 220 gig streams. When they get saturated, and this goes perfect into planning, that we can even look at our visibility fabric links and see where they're getting choked. Are we bringing too much into our aggregators? So we might be bringing 24 10 gig interfaces into an aggregator with 240s on an uplink. Well, you know what? We have to look and say, are we starting to use more of that? Are we choking the uplink? At that point, do we need another aggregator? Is that a heavy traffic thing that we should just take directly into the director, maybe that 10 gig? For 40 gig, we have a different set of aggregators. So this gives us the ability to plan also on the visibility fabric. Now, the great thing is we've pulled everything off on the taps, and we've got our own network running behind the scenes. So we have a kind of like a, I've heard a lot of people refer to it as different things, but the industry refers to it as like a shared, like a data access network. So we've pulled all of our production traffic off and we've moved it onto another network that's not really production that allows us to get it to any of our tools that need to get it. So one of the things that we do, especially with voice traffic, is we drop the payload. We don't want to record any voice. State that up front. We don't record any voice on any of our stuff. We just want the MOS scores. So as soon as it tapped and it hits our director, they go right in, drops a voice payload, keeps the analytics, sends it over to our analysis tools. But in this case, our analyzers are located in different facilities. So I showed that we had the 2 20 gig connections between, or the 2 10 gig connections, it's 20 gig, between our intelligence at each of our data centers. In one of our data centers, we have a system responsible for voice. And we send all of our voice data for voice analytics to that, where we send all of our other application traffic over to our primary ARX system. And that gets the bulk of it. That box just sits there and cranks away at our major apps. That box is going to be getting a facelift soon. Right now, it's only got 24 terabytes of storage capability. We're moving that to 124 terabytes coming up. So probably in the next 4 months, our new budget year hits in July, so till we get there and order the product and get it in, about 4 to 6 months, we're going to have our new system in place. That just means that old system will be then redeployed and it'll move down for some of the, probably replace our 3100, and we'll keep running it for our voice analytics. But this picture gives us the ability to take data anywhere that we're fanning our 7Ks or 5Ks out, any of our core links, any of those links. It gives us the ability to bring those and put them into the visibility fabric. So once we get that data, we can move it anywhere we want. After we do all of our header stripping, our dedupe, our packet slicing, we can send it over to a long-term storage. We can send it over to analytics boxes. We can combine that traffic. We could even do net flow generation out of it. Some of these modules have the ability to do net flow. So hey, imagine now you start stripping out, you dedupe your traffic, or you do your header stripping, you dedupe, send that over to a net flow, drop your payload and send that header information over to something generating net flow and send it into your net flow analyzer. You don't necessarily have to have a Riverbed Steel Central system, and you could be using existing net flow analysis. Still put your higher speed gear in, but let your directors and your intelligence there generate your net flow. So maybe you have a different box that's generating net flow. And what's great is you can say, okay, I'm going to send this application traffic here, this application traffic here, and I'm going to take all my traffic and send it out these couple of ports over to these boxes that are going to convert every one of those to net flow and send it into my net flow analyzer. So what's the future hold? Not just the future for us, the future for enterprise, healthcare. For us, everybody has to look and say, what's their end future? What's it going to entail? Is it going to entail 100 gig links, 40 gig links? Next is 7K, 6K, Juniper systems. Whatever the case may be, what does the future hold? So for us, we've built our network as our core is MPLS. I can provide services all over the enterprise. We haven't expanded MPLS into the data center yet. Our ASR 9K cores are the ingress LSRs into our MPLS network. I haven't moved it down to the 7Ks yet, but that's coming. We have the ability to deploy advanced services to the edge. So I can treat each of my closets as a metro edge. I can generate a pseudo wire from any of my closets to anywhere else in the enterprise to deliver advanced layer 2 services or do like a VPLS style connection. The use for that is I may have a piece of medical equipment that's distributed around the hospital, but I want to bring it back to central firewall because I want to protect it. I can do that with all these advanced services, and that's how I provide that. Higher speed modalities in the future. So when it comes to imagery equipment, you're going to get better resolution CTs, better resolution PET scans. They're going to be more slices. They're going to be higher resolution. Now, it's not inconceivable that a single study could be almost a gig, depending on what's being done. For our electronic medical record, we have our infusion management, which are all our pumps. I talked about the infusion pumps and how they're auto-programmed. Physiological monitors that tie back in, show waveforms back in the EMR. CPOE, which is our physician order entry system, so they can do all of their med administration electronically. And we use barcode medical administration. So I can scan a barcode, nurse can scan a barcode on a patient, scan the medication, give the patient the medication, and have it registered that the patient was administered the medication. I can wheel a pump into a patient room, scan the patient, scan the pump, link the two together, scan the medication that I'm going to be hanging on that pump, scan whatever I'm going to be hanging on that infusion pump. The system then looks back in and says, hey, that was a prescription order. I'm going to automatically program the pump. Nurse doesn't have to punch anything in. She just brings the medication in, scans it, hangs it, the pump gets programmed. We do this because these are our friends and family. These are our neighbors. We have patient lives on the line. We want to build a network that's secure. We want to build a network that can grow, that's scalable, functional, one that we can troubleshoot. Because at the end of the day, it doesn't matter the latest and greatest widget that I'd like to do or that anybody else would like to do. At the end of the day, it's all about the patient. How can we treat the patient? How'd you like to be sitting in a doctor's office getting bad news from an oncology doctor that you got cancer? And he can't get into the medical record to show you. Or his machine keeps crashing. Let me tell you, that patient doesn't care whose fault it was. Server team, network, the doctor. It doesn't matter to him. And the reality is, it shouldn't matter to him. Because what's going to matter is their anxiety for what the doctor's telling them. And that's why we do it. So I told you about who we are, what we do, but this is why we do it. At the end of the day, we do it for them. So how are we going to evolve? We're going to have to deploy more intelligent directors. We're going to have to get better with header stripping on our MPLS as we deploy that into the data center. We're going to slice our packets, keep only what we need. We're going to have to aggregate more 10 gig links into 40 gig, maybe even 100 gig. We're going to have to do it at a rack level. We're going to have to deploy more analysis systems to provide performance monitoring for specific applications, which could be every single application we have. And we're going to have to implement a way to plan our network and our transport network, our data network and transport. So we got to look at our fiber capacity as well as the interface capacity. And that concludes my part of the presentation. So at this point, I believe we can open this up to any questions. So I don't know if anybody's submitted any questions there, Jake.
Thanks, Randy. No, that was a great job. I haven't seen any questions come through, but I'll keep my eye on the Q&A feature here if anybody has one now. I just wanted to say thank you, Randy. Great presentation. I hope all of our attendees found it as informative and valuable as we did. Thank you all for attending today. Randy, thank you again for your presentation.
You're welcome, Jake, and I want to thank everybody else for attending and taking the time to listen to me, so I appreciate that.
All right, great job. Thanks, everybody. Have a great day.